you have not signed in, please do so around the break. And just, I'm at the back there, so you can come up to me after, around the break to sign in if you have not done so. All right, thank you.
All right. Welcome, everyone. Thank you so much for being here. It's a real pleasure. My name's Kevin Markham, and this is Using Pandas for Better and Worse Data Science. It's my privilege to be here today. So before I start talking about the tutorial and what's going to happen, I'm just going to tell you real quick about setup so that if anyone who's not done setup yet can go ahead and do that. And so what you need to do, if you haven't already, is go to the GitHub repository. I've got these bit.ly links, bit.ly using pandas. And even if you've already set up your system, go ahead and go to that GitHub repository. And once you're there, you can get the data files. If you haven't already, there's some instructions on the page for how to download them if you're not familiar with downloading from GitHub. And then you'll want to open your Python environment. You can use any Python environment. I recommend using the environment that you're most comfortable with. I'm going to be up here using the Jupyter Notebook, but you do not need to do that at all. Just use whatever you're comfortable with. When you've got those files downloaded, put them in a place that's easy to access. Usually it'll be in the same directory as your script or your notebook, and that'll make it easiest to access the files. I've got some instructions on the page for how to check that pandas and matplotlib are properly installed. Those are what we're going to be using in the tutorial. And if you're having internet problems, or you are just like, wait, I forgot to bring a laptop with pandas. I have 5 flash drives up here. All 5 of them have the data files on them if you need them and can't download them. And then 3 of them also have Linux, Mac, and Windows versions of the Anaconda distribution, which is pretty big, but you could definitely install it in a few minutes if you need it. So if anyone needs figures out they need one of those flash drives, just come up here and I'll give you one. Okay. All right. So while people are getting settled and set up, I'll tell you a tiny bit about myself and then talk about the tutorial. As for me, I used to live in Washington, D.C., and recently moved to Asheville, North Carolina in September with my wife and my son. I'm the founder of Data School, and I teach data science in Python online. I'm mostly known for video tutorials on YouTube. Anyone ever seen one of my videos? Cool, cool. Thanks for watching. And I used to do a lot of classroom instruction in data science through General Assembly in DC. Really enjoyed that. So it's nice to be back in front of a classroom because right now I teach online only. And I was at PyCon 2016 doing a tutorial called using, what was it called? It was machine learning with text in Python 2 years ago, and that was really fun, and that's that. So let me talk a little bit about the tutorial format so you know what to expect. The goal here is to help you become more fluent at pandas to solve data science problems. Okay? So I am assuming you know some pandas. This is not an introductory tutorial. I don't assume you know much or anything about kind of the data science process. We're going to be doing a lot of exercises. This is very exercise driven. And we're between the 2 data sets. We're going to start with the police data set, and then at some point we'll move on to the other data set, depending upon timing. How it'll work is I'll give you some sort of question or task, and you will try to work to answer that question with pandas. And then, I'll give you a couple minutes or however long seems reasonable. We'll talk about the answer together, and each exercise will conclude with some takeaways for here are the things I was trying to teach you through this particular exercise. And some of the lessons will be very pandas specific lessons, and other will be more general data science lessons. In terms of the pacing, we are, please keep in mind that everyone in the room is going to be at a different experience level. And some of you who are more beginner might find that this goes way too fast. And others who are more advanced might find that it goes too slow. and I'm going to kind of aim for the middle. So I'll be kind of watching how people are doing during the exercises and answering questions. And at some point, I will just kind of stop and we'll move on. So I'll do my best to kind of split the difference and head for an intermediate level. If you do finish early, please help your neighbor. Please help each other. I'll be walking around, but there's only one of me. So feel free to help each other. And if you're at any point struggling, there are more seats throughout, so feel free to wander wherever. If you find that you're struggling and you're like, boy, this is really hard, don't worry about it. It's not a big deal. There's going to be, most of the people in the room will not get everything. And it's okay if you're only picking up certain pieces. Totally fine. And the other cool thing is that most of the exercises are completely independent. So if you miss exercise 1, 3, and 4, and 6, and 7, you're going to be fine on 8, 9, and beyond. So don't worry if you miss something, you will be fine. There's a couple times where that's not the case, and I will say, you need to type this line of code so that it will work for future exercises. So you are not going to get lost, or I hope you won't get lost. We will help. All right. Final thoughts before we start. If you have not used the Jupyter Notebook before, which, as I said, is what I'm going to be using, it's probably not the best time to learn right now because it's a very different kind of environment than you might be used to. You can ask questions at any time, and if it's beyond the scope of what I want to talk about today, then I'll just tell you and we can talk about it afterwards if I even know the answer to your question. The break, as she said, the break is at 3 o'clock. It'll be hopefully from 3 o'clock sharp to 3:20, and then we'll start right back up. We end at 4:40, so it's 3 hours of actual content. And after the tutorial, I will post all of the code on GitHub. So if you want to follow along and type everything I type, you can. If not, there'll be reasonably well commented code on GitHub afterwards that you can refer to. All right, enough me talking on and on. Any questions for now before we jump in? Any questions? Awesome, awesome. Okay, so I've got my Jupyter Notebook open that I'm going to be using, and we're going to start just doing some imports, and then we're going to talk about the first data set briefly and kind of do a little refresher on pandas before we actually do the first, quote, exercise. Okay? So, of course, we'll go ahead and import pandas as PD, and if you don't use matplotlib much, no worries, but the standard import is import matplotlib.pyplot as PLT. Okay. How is the font size in the very back? Is it okay? Bigger? All right. All right. How's that? All right. And if you are in the notebook, but if you're not in the notebook, this is irrelevant. But if you're using the notebook, for certain versions of the notebook, you need to say %matplotlib inline, okay? If you're not in the notebook, that's not relevant, and it's no longer relevant for certain versions of the notebook, but it'll allow plots to appear. Okay, so first data set. Dataset 1 is from the Stanford Open Policing Project, okay? And I can tell you the URL. It's linked. This will only take a minute. We're just going to go to the web page of the dataset, and you can scroll down on the GitHub repository to this link to Stanford Open Policing Project. Let me make that bigger. And this is not critical if your internet is flaky. The Wi-Fi is open. It's 2018 PyCon. This is the Stanford Open Policing Project's website. You don't need to read it. Just saying this is a data set of 31 states and police traffic stops in those states, okay? And if you did come to this page, I want you to click that View Data button, and then it'll show you, if you're interested, you can see all the states and what data fields they have on the bottom. But really, I wanted to bring you to this. There's a link here that says README, and not critical, but it's a README file that talks about some of the columns. At times in the exercise, it might be helpful to have this page. So if you're trying to decode something in the data set, you can always come back to this page. And you can ask me later if you got lost how to get here, and I can pull it up on your machine. But this is some data about the data set. The data set we're using is from Rhode Island, and I just picked it because it's a nice small data set, but a lot of the fields are there. I decreased the size from the one that's available online by randomly sampling it 20% of the rows and removing some of the columns that didn't interest us. So those are the only modifications I've made. Everything else is as is. Okay. All right. So let's go ahead and read it in to pandas, and then again we're just going to talk about it briefly, and then we'll jump into the first exercise. So I'm gonna create a data frame named RI, short for Rhode Island, because it's nice and short to type, but you can use something else if you like. And this will actually just be a simple read CSV command of police.csv. Okay. And you shouldn't get any errors on that, and you don't need to change any of the default read CSV parameters. All right, so starting now, I'm going to be asking lots of questions and throughout the tutorial, so lots of participation. So this is the head of the data frame. What does it look like each row represents? And either you can raise your hand or just call it out. An incident, a traffic stop. So, you know, it looks like, okay, a date, a time, an age. So this must be each row is one traffic stop, okay? And then if you use ri.shape, the shape attribute, what do these two numbers represent? I'm sure someone said it. Number of rows, number of columns. So 91,741 rows, 15 columns. And then let's just take a look real quick at the D types. And I know we barely look at the data set. You'll have plenty of time to do that during the exercises. I'll focus you on certain columns. But here are the data types. So I just need a volunteer to explain what these different data types mean real quick. Who wants to do that? Okay, object is a string, so probably some sort of category. It can actually be an arbitrary Python object, but it's usually a string. And then float and bool, so what are those? Right, so the floating point numbers, and bool, short for Boolean, which are true, false values. Okay, so just useful to keep in mind what the different column types are that we're going to be working with. And let's scroll back up for a second, back to the head. And we've got this NAN here in the county name column. What does NAN mean? Not a number, and more generally, like, what does it indicate? Missing value, someone said, or lots of people said. So NAN indicates a missing value. It's a special value in pandas that indicates the value is missing. So why might a value be missing? Why might it be missing? It wasn't recorded at the time. That's one. That's the usual answer. Great. And can anyone tell me one other reason a value might be missing? One more time. Data corruption. Okay, great. Any other reasons? Yep, in the back. Redacted for privacy. Great answers. The one other I would bring up is that it's not like a value can be missing if it's irrelevant for a particular row. So if you had a data set of Python users and there was a column called like attending PyCon 2018 that was true or false, and you had another column called PyCon 2018 registration date, that would be a missing value for anyone who's not registered for PyCon. So it's not that we didn't want to collect it, it's that it's irrelevant. Okay, so because the person is not attending PyCon, they don't have a registration date, so you would make that like a missing value. So the point there is values can be missing for different reasons. Sometimes you wanted to get it and you couldn't. Sometimes you have it, you got rid of it, and then sometimes it's just not a relevant value. Okay. And why would we mark something as NaN rather than just like a 0 or an empty string or the text unknown? What's the value of having NaN? How about there? Right, right. You want to distinguish, he said you don't want to screw up like your statistics on a column. So basically, you want to be able to distinguish what is real data from what is like marking. Like if you typed the word unknown in a string column and that was like a last name field, what if someone's last name was unknown? Or how do you distinguish the missing data from the real data? So that's why you mark data as missing. Okay. All right, I swear we're almost at the first exercise. I'm going to just type one more line of code, and I want you to tell me what we're doing. ri.isNull.sum. Okay? All right. ri.isNull.sum. I have two questions. What do these numbers mean? And then second is going to be, how does this line of code work? So what are these numbers? The sums of all null values in each column, or more generally, just like, what does this represent at a high level? The count of missing data in each of these columns, okay? So stop date has 0 missing values, stop time has 0 missing values, etc. Now my other question is, how does this line of code work? Who feels like they can explain like the 2 steps that go into this line of code? Right there.
You're returning an array of trues and falses.
Okay.
Then doing some operation on that.
Right. So our first step is ri.isNull, which is a data frame method, and it returns a data frame of true values and false values. And then when you take the sum, okay, you're taking a sum of a data frame, and you might think, well, what's that going to do? Well, it does 2 things. One is it sums over the 0 axis, the index axis, so it kind of collapses all the values down, like the math. I think of it as the mathematical operation goes down, or you can think of it as the dimension of the data that's being collapsed is the 0 axis. So it does the sum in that direction, such that you end up with column sums. And the other thing it's doing is translating true into 1 and false into 0. And if you didn't know that true actually is equal to 1 and false is equal to 0, which is why you can add together Boolean values. Okay? All right. So let me delete that to clear the screen here. Okay. So let's get into our first exercise and get you guys and girls typing and writing some code. So here is our first exercise, and it is to remove the column that only contains missing values. Okay? Remove the column that only contains missing values. It's not a trick question. So I will give you just a few minutes for this. And as I said, if you already know the answer, help your neighbor if they're struggling. But remove the column that only contains missing values. I'll be wandering around, and then I'll be back up front in a few minutes. Okay? give you all, say, 2 more minutes. And I know some of you are, of course, done, but don't overcomplicate it. You can do it in 1 line of code. There are multiple options for how to do this, so don't don't make it too complicated. All right, let's go ahead and go through this one. So there's one way you could have done this that you don't really need to know what column has missing values, but let's assume you care what you're dropping. So what was the column that only contains missing values? County name. All right. How did you know it was only containing missing values? How about?
I mean, so there are only, what, 91,741 rows, and all of the county name rows are null.
Right. Great, great, great. So I'll try always to repeat what anyone says because I know you can't hear behind the person. So he noted that the shape is 91,741 rows. He also noted that the number of missing values in that column is 91,741, and that's the only column with all missing values. So that's the only column to be dropped. Okay. So what is one data frame method we can use to drop a column? Drop. All right. And we're going to pass it county name as a string. What are the 2 parameters I want to specify? Axis. Okay. And what is the axis? You can either use axis equals 1 or axis equals columns. It changed, maybe a year or 2 ago that you can now name your axes in, I think, every function either as 0, 1 or I think index columns or maybe rows columns, but I think it's index columns. Anyway, you have to specify the axis. And then what is one more argument that I need to specify? In place. All right. Thank you. So in place equals true. Now, why do I need to say in place equals true? Right. It doesn't. If you don't say in place equals true, the default is in place equals false, and it just kind of does the operation, shows you the result, and throws it away. So in place equals false is kind of like doing this, okay? Did anyone just do this? Yeah, it's fine. And as far as I read, I don't think it's actually more or less memory efficient or whatever. But this is kind of a little bit more Pythonic, maybe. In place equals true, okay? So after we do this, and remember, you can ask questions at any time. So if you're like, what does that mean? Let me know, and I'll try to be watching. So you should check your work, and check that there's now one less column missing, or sorry, one fewer column there. And you could even check the columns attribute to see that it's gone, and it is indeed gone. What was another method we could have used to do this task? All the way in the back. Drop NA. And that's, a little nicer in the sense that you're just saying, I want to drop all columns which are missing, which all its values are missing. Okay? So that would have worked, but we've already dropped it, so it won't do anything. I mean, it won't change anything, but it won't do anything. All right, so that's the end of that exercise. That was what I would consider an easier one in comparison to the rest of the exercises today. So you can get a gauge of how this is going to be. In terms of the lessons, and I'll go back to that screen in a moment, but I've kind of pre-written so I don't have to type it right now, what my lessons are for each little exercise. And what are my lessons for this one? Number one, pay attention to default arguments. For instance, you need to change the axis argument. You need to change the in-place argument. Otherwise, you would not have done what you wanted to do. You should check your work to see if what you think you meant to do actually happened. And there's more than one way to do everything in pandas. And you just I guess you have to get comfortable with that idea that there's not just one right way to do everything. There's almost always multiple ways to do everything, which is kind of maddening at times with pandas, but it is kind of the way it is. Okay. All right. Any questions about that exercise before we go on to the next one? Yeah.
So what would be the reason to not delete that column but just del RI?
Right, that's fine. He was asking if you can just use the del keyword statement. I don't know. If you can just use del like RI bracket, yeah, and then column name. You could do that. That's fine. It's a little bit less pandas-esque. It's not pandas, so it will work, but I always prefer in pandas to use pandas operations. So that's really it. Great question. Other questions? Okay. All right, next exercise, number 2. Do men or women speed more often? Now, this data set just has men. This data set has a driver gender column. It only is M or F, which is why I phrased the question as I did. So my question is, do men or women speed more often? I am not going to clarify the question. You are going to have to figure out how you want to answer that. Not how you want to answer that. How you can go about answering that question given the data you have. And the columns you want to pay attention to are, and I'll just type them so you can see them up here, are driver gender and violation. Okay? So those are the 2 columns you need to pay attention to in order to answer this question. Answer it however you like. If you come up with an answer, think of a different way to answer the question and try it again. But be comfortable with the ambiguity I've given you. Okay? And as always, I'll be walking around. let's see. Yep, it's on. Who would like more time? Okay, it seems like you've either got it or you've kind of given up, which is both fine. All right, let's get started here. So there are different ways to answer this question, and I think I know what most of you probably headed towards. So we'll start with that, and that's thinking of this question as when someone is stopped for speeding, how often is it a man versus a woman? So that's how I would kind of clarify the question. And so you might start by filtering the data frame. So if you're not familiar with, if you want to filter for speeding, which is what I would start with, case sensitive, of course, so you need to make sure to get the capital S on speeding. So you could filter it by all the speeding violations, and then select the driver gender column, okay? And then what might I throw on the end to give me an answer here? I heard a sum. That's not quite what I was looking for. Count. I don't think that's going to do it. No, that won't quite do it. What I was actually looking for was value counts, which is a count of values, okay? So this immediately tells you in this data set, filtered by speeding, select the gender column, count how many instances of each. And then what if I want these as percentages? Anyone know this one? There you go. Normalize equals true, okay? So we know that if when someone is stopped for speeding, 68% of the time it is a male and 32% of the time it's a female. So that's one way to look at this. A different way to look at this would be like when a man is pulled over, how often is it for speeding? And when a woman is pulled over, how often is it for speeding? So it's kind of like flipping it. And you would just do the filtering the opposite way. So ri.driver gender equals male. And then from there, you would select violation, okay? So, and then I'll do the same thing, value counts, normalize equals true. So all I did is flip the ordering of what I'm filtering by and then what I'm selecting. So, and in this case, I'm seeing, okay, among males, when they are pulled over, 52% of the time their violation was speeding, okay? And if we want to duplicate this, I know if you're not familiar with the filtering, this is going to, you're just going to be like, what is that? So I understand if that looks completely foreign. I know it's confusing. It took me a long time to figure out like why I have to type RI twice, but you do. So for females, when they are pulled over, 65% of the time it's for speeding. So you could argue that the first way gives us an answer of males, the second way gives us an answer of females. And there's not necessarily a right answer because it was an ambiguous question. But here's a pandas question. If I wanted to get all of this that you're seeing right now into one line of code, what would I do? And I've already heard someone say it recently. Like, what's the method I need to use? Sure. A group by. So group by, driver gender, and then all the same stuff. Violation, dot value counts, normalize equals true. Okay? And now you have all that same data in kind of one compact form. So group by is like, for every gender, I want to select the violation column and do a normalized value counts. Okay. So, sorry if that code is a little fast for you or over your head. Don't worry about it. In answering the question, do men or women speed more often? What's the data what's the relevant data that we're missing?
We don't know how many miles men and women drive.
We don't know how many men or women are driving in Rhode Island. We don't know how many miles they drove. What else do we not know? Um, well, that's kind of the question we're trying to answer, but you're getting at like we don't know like number one, maybe some people, I mean a lot of people drive just over the speed limit and technically you're speeding and you don't get pulled over, or maybe you do it strategically. So there's lots of data we don't really have that we could use to answer the question. So I'm not saying we necessarily have the data to answer that question. So really my only lesson in this little exercise is there's more than one way to understand a question. So I would encourage you when you get a data science question to kind of like interrogate it and ask, like if someone's asking you, you ask them details about what they really mean, and then you tell them the data you're missing that would help you better answer it. And then when you give them an answer, you say, well, given what I have, given that I answer it this way, here's what I really mean and what the caveats are of that. So that's kind of the data science lesson here. There's more than one way to answer a question. Okay. Questions before we move on? Yeah.
Is there a way to specify in the group by statement, like I'm just looking at speeding? Is there a way to like filter out the other violations there?
Yes, you could, like from right here.
Yes.
Oh, sure. Yes, you could do .loc. I think this will work. I think that was, yeah, that did it. So this is a series with a multi-index, and you can select out of those with loc using essentially like colon means all of the outermost index, and then I want to select speeding from the innermost index. It's kind of like having a data frame with, it's kind of like you just think of this as a data frame, and how would I select the rows and the columns? And in fact, if you unstack this, you get a data frame that you could use loc with kind of more naturally to select rows and columns. That's a little bit more advanced stuff. Okay. All right, let's move on to the next one. I realize we're only on number 3, and I've got many, many exercises. All right, does gender affect who gets searched during a stop? Okay, and the relevant columns here are driver gender, like before, and search conducted. So that's all I'm going to say about it. Does gender affect who gets searched during a stop? And those are the 2 columns that are key. There might be things from the previous exercise you can use, or there might not. Do your best, and I'll be walking around. Who would like more time on this? Okay. All right. Let's go ahead and go through this. All right. Hope that was fun. So first, let's just forget about gender. So a lot of times when I'm doing something in pandas, I try to simplify my task before I try to really answer the question. So let's look at searches, okay? So if we have just ri.search conducted, and you've probably noticed that I use dot notation basically. That's all I use. I don't use the brackets. So if you're not used to seeing that, my apologies, but it's all I do is the dot. So if you had search conducted and you just wanted to know, hey, what's the rate of searches? You could just do value counts and you could normalize it. Whoops, sorry. And there you go. This is the baseline search rate. Okay. So and this is if you're like, what do you mean exactly by search? I mean a search of your vehicle during a traffic stop. So in Rhode Island, within this data set, out of every 100 people who were stopped, 3.5% of them had their vehicle searched. So that's what this means. Okay. So he asked if I could display the counts and the percentages at the same time. There's probably a way, but it's probably a lot more code than you'd want to write. There might be a slick way, but I don't know it offhand. So, all right, let's get back to that. Normalize equals true. So this is our baseline search rate. 3.5% of stops results in a search. Okay, so I'm going to show you a line of code, and I want to know how it works. ri.searchConducted.mean gives me the same number as that second number. How does that work? One more time. True has a value of 1 and false has a value of 0. So when you take the mean of a series of 1s and 0s, you get the percentage of times it is a 1. Okay? So this is a neat trick that will simplify some of your pandas code. If I saw in just talking to people, I saw a lot of value counts, which is fine, but you can simplify your code even further if you're, let me restart that sentence. If you're doing a value counts on a Boolean column, often, I mean, you're just going to get counts of 0s and 1s, and you can always just get a sum to know the number of 1s, or a mean to get the percentage of 1s. So it'll simplify your code, and what I mean by that is this is what I was going for. Whoops, sorry. I'm going to group by driver gender. So for each gender, because in your head when you hear for each and group by, those are equivalent. For each gender, I want to get the mean of search conducted. I want to get the percentage of trues for search conducted for each gender. So this is what, if you got these numbers in some form, that's fine. This is kind of what you're going after is, okay, for females, they are searched at a 2% rate. For males, they are searched at a 4.3% rate. Okay? So my one question is, does this prove that gender affects who gets searched? Does this prove?
No, because we have no idea what the males and females did to give the police officer probable cause.
Right. So he was saying we have no idea what gave, like, why they were searched. Like, what was the probable cause? Is it that males are, like, meaner when they get stopped? I don't know. No, we don't know. All we've looked at is gender here, okay? All we've looked at is gender. Now, let me give you a hypothetical, okay? And the hypothetical would be that when people are pulled over for seatbelt violations, okay, which is in the data set, they are rarely searched, let's pretend. And when they're pulled over for registration violations, they're often searched. And maybe that's because if you interviewed a police officer, they said, oh, those seatbelt people, they never did anything wrong. But those people with the registration violations, that was like a pretext for searching them, and they looked shady. I don't know. You could, if you interviewed a police officer, they might say, here's how we decide. Well, the registration violations, it turns out, we think we should search them. So it could be that search rate is tied to violation and that men commit more registration violations and women commit more seatbelt violations, okay? So that would be one hypothesis where gender is actually irrelevant to the question of like why there's that difference, why males are searched at twice a rate. There could be some other underlying factor. And so if you wanted to test that idea, and if you got lost there, it's okay. I think this code might help. If you wanted to test that idea, you might actually just do a group by with a group by on 2 columns. Okay? So if you didn't know, you can group by multiple things at once. You put them in a list, and then you list the columns as strings. Okay? So all I did is I increased the group by to be grouped by 2 things, dot search conducted dot mean, and this is where the dot mean comes in much handier than value counts because it gives you that percentage. Now, if the searching was really because of violation type, what we would see is that males and females were like searched at the same rate for each violation. And then we might think, oh, males and females are committing different proportions of violations, and that's why males are getting searched at a higher rate. What do we actually see here? If you had to summarize this in like human terms. Yeah, in the back. Right, so males are getting searched at a higher rate for almost every violation, okay? Other than this other category right here. So, because you'll see the numbers are much larger for each violation type between males and females. So, does this prove causation? And the answer is no. So this is, first, this is not a workshop about causation. I wouldn't know how to teach that workshop, although I do know that if you were wanting to figure out causation, you'd probably talk to some experts. You might gather different types of data. You might design experiments. You could yourself come up with more hypotheses and test them with the data you have. The lesson here, there are 2 lessons. I have one is that causation is difficult to conclude, so focus on relationships, okay? Sounds like marriage advice. Focus on relationships, not causation. And include relevant factors when studying a relationship, okay? So if you did that first group by and you saw, okay, males have a higher search rate than females, you could just say, I'm done, or you could realize, well, there are other possible factors, and there's a lot of data I need that I don't have. So when I do data science, I speak in terms of relationships only, not causation, because I don't know how to do that, and I'm not an expert. Sure. Right. So the question is, in data science, if you're talking about relationships, are you using statistical tests, essentially? And the answer is, my answer is, there are many methodologies to getting at the answer you want. Sorry, I don't mean to getting the answer you want. I mean, there's certainly that. What I really mean is there are many methodologies in data science, and some methodologies use a certain set of tools, and other methodologies use a different set of tools. And if you were talking about, I want to prove causation, I'm positive you would use statistical tests. If you wanted to talk a relationship, we didn't answer the question of the strength of the relationship or whether it's a significant relationship. All we're trying to look at is, does there appear to be a relationship based on what we have? I don't know if that was a satisfactory answer, but I'm happy to talk afterwards. Other questions? Okay. All right. Let us move on to the next exercise. All right, number 4. Should we do this one? Now that I'm going to just see, which exercises do I think will be the most interesting? I think I may actually just do this one as a demo, okay? And then we'll do the next one will be on your own. Why is search type missing so often? Okay. So, we'll just do this one quickly because I want to make sure we do. There's a lot more interesting ones, and I wanted to get into some visualizations. So, let's go back to this ri.isNull.sum, okay? And as a reminder, this is the number of missing values in each of the columns, okay? And if the question is, why is search type missing 88,000 times? And anyone have a theory about why it's missing so often? Yeah, in the back. Right. So we think 88,000 times there was no search done, which is why that value is missing. So if I wanted to check that, I might say, well, let's look at the search conducted. Okay. And I would see, oh, look, searches were conducted they were conducted 3,196 times, and they were not conducted 88,000 times, and that is the same exact number in which search type is null, okay? So that's pretty good evidence that search type is missing anytime search conducted is not done. Yep. Is null? No. We are, okay. Oh, great question. Okay. So search conducted is true or false. Search type is, let's just look at search type. ri.searchType.valueCounts is a bunch of categories. It's not a true-false. It is a what is the type of search. And you would have discovered that on your own when playing around with the data. Sorry, I assumed, obviously it's not obvious. So if we made this conclusion that, okay, well, these numbers are identical, thus search type is missing anytime a search is not conducted, there are various ways we could filter the data to prove that. And the point I'm driving at, I'll actually show you right here, which is let's filter anytime ri.searchConducted equals false. Okay? And then we select the search type column and do a value counts. Okay? So it gives us an empty series. So this is filtering the data frame by search conducted equals false. So when is a search conducted? What are the value counts of search type? And my question to you is, why is this an empty series, not a usual output for value counts? Anyone have an idea? In the back, yep. Right. The search type is always null, or NA, or NaN rather. So there's no values to count. And the other way I would say it is that by default, nulls or NAs are dropped in pandas methods. So drop NA equals false will show us that value counts actually drops null values by default. Okay? And that's what I want you to be aware of. So if I do drop NA equals false on search type, you'll see that value counts actually has all those NaN values, but pandas kicks it out by default. And that's just kind of a useful fact to know about pandas functions in general. They ignore missing values by default. The other lesson on here is when you see these 88,000 numbers matching, I encourage you to kind of verify those assumptions. I think that every time search conducted is false, search type is null, well, it'd be good to write code to check that if you're going to depend on that assumption. Okay. So I know I went through that kind of quickly. I wanted to, the next exercise kind of builds on that. So I wanted to make that clear that you need to be thinking about your nulls when using any pandas function. So let me just give you the next exercise. And if then any questions came up, I'm happy to answer them. During a search, how often is the driver frisked? Okay? And let me just, if you didn't notice, what we've got in search type value counts, and sorry, I'll show the question again in a second, is these protective frisks, okay? And you'll notice that if there are multiple search types, they're listed separated by commas, all right? So with that in mind, the question again is, during a search, how often is the driver frisked? Okay? So that's the question. It's 2:45, and I may try to come back and do this before the break. We'll see how people are doing. But yeah, let me know while I'm walking around if you have questions. So it's 2:57. I can either start explaining now and see how far we get, and we'll break right at 3, or I can wait till after, and you can take some additional time on this one. I guess the third alternative, well, the next exercise isn't related, so I don't want to start that before going through this one. But I guess, would anyone like more time right now? Otherwise, I can just start talking for a couple minutes. Okay. All right. So during a search, how often is the driver frisked? So many of you seem to have figured out that we need to identify all the cases in which these search type values contain the string protective frisk. Now, if you were just looking at, actually, let me go ahead and show you that. So what is the method, what is the method we would use that a lot of you came up with for searching within a string? String contains. So there are Python string methods, and then there are pandas string methods. And pandas string methods are like a string method that you apply across the entire pandas series. So if I say ri dot search type dot str dot contains, and then I pass it, you could just do frisk. I did the whole string protective frisk. Okay, what you actually get is a lot of NaNs anytime search type is missing, and then you get true values anytime there's a match, and you get false values when there's not. Okay, so it's a string method that automatically operates on every element of the series. Okay, so I'm just going to create that as a new column called frisk, and then ri.frisk.valueCounts to see what we got. And you'll see that there are 274 instances of yes, there was a frisk, 22 instances of no, there was not. And then if you were thinking, we were talking about this whole drop NA argument, let's go ahead and make sure there are some NaN values. And in fact, string contains preserves those NaN values. All right? So those are preserved. It didn't say, well, like you could think, well, how should I handle if I check if a string is contained in a null? Well, I know the answer is no, but should I return a false or an NaN? And by default, it returns an NaN. I think you can have it return a false instead. But what that gets us is now we can just, what that gets us is we can actually just say ri.frisk.sum, and we've got our 274. Those are the true values. And then we say ri.frisk.mean, and we get the percentage of true values. So 8.5% of the time, when there is a search, there is a frisk. Okay? If you got a much, I could say a lot more about this, but I want to get to the break. So if you got a much smaller percentage, you are probably calculating amount of frisks out of all rows. Okay? And the important thing here is I said during a search, how often are they frisked? And you'll notice that even the mean method is smart enough to ignore the NaN values. Because if you're not doing the math in your head, and why would you be? We've got computers. You would say, 274 plus 2922. Okay? So that is that percentage that the mean method generated is the same as the 274 over the falses and the trues. It did not include, it excluded the missing values. Okay? So again, pandas excludes missing values by default all over the place. Okay? I'll let you guys go. The lessons I had for this one is just using string methods. If you're working with string data, you should be using string methods in pandas. Make sure you've got the right denominator when you're calculating rates. Okay. Pandas calculations ignore missing values, and then when you get your results, you always use the smell test, look at it and say, does this seem about right? Like, does this make sense in the real world? And if not, check your code, okay? So it's 3:02 now, and we'll start back right at 3:20. But go ahead and go to break, and I will mostly be in here, and I can answer questions during the break, okay? All right. Hello, everyone. All right, we are going to go ahead and get started again. Hope everyone had a good break. So I'm just going to, before we do the next exercise, I just want to do a quick check. So I want to figure out, on the whole, are we going too fast, too slow, or just right? So what I'm going to ask you to do is just put up a thumb, and thumb up means like speed it up. Thumb down means like slow it down, and thumb to the side means like we're just right. So what do you think? Okay, so I'll process all this data. I just see what. Okay. Processing. Okay. All right. I've got a lot of same pace, a slightly less amount of speed it up, and a lot less slow it down. So I'm going to take that into account the best I can. All right. So next exercise, we're going to jump right in, and the next few I think will go faster, so you can see more concepts. But the exercise is number 6. Which year had the least number of stops? And that is all I am going to tell you, and I'm only going to give you a few minutes for this one. Which year had the least number of stops? I see a lot of heads down and like focus, so it seems like a lot of folks are still working on it. So I'll give you another maybe 2 minutes, see if you can come up with an answer. All right, I see less focused faces and people typing, so I think we'll go ahead and go through this one. I saw a lot of Stack Overflow, which is, I don't know, a good sign or a bad sign, I'm not sure. But all right, did anyone use a string method to solve this? What string method did you use? First 4 characters of the stop date column?
Yeah.
And what specific method did you use?
Well, just the bracket colon 4.
Oh, okay. All right. All right. Did anyone use a string method like an actual
String split with a hyphen.
Okay, string split with a hyphen. Okay, so that splits on a character you select. Anyone else use a different string method? Maybe in the back corner? Slice. Slice is the one I chose because I thought it was the most straightforward. So as we saw in a previous exercise, you can use string methods across a series, and they all start with .str. They're series methods, so data frame name, series name, .str, and there's lots of them. And I like slice in this case, and I want to slice from characters 0 through 4, okay? And that outputs a string series. And then you can just throw a value counts on the end. And that would be one way to do it. And you'll see that the year with the least number of stops, because every row represents a stop. The year with the least number of stops is 2005. Did anyone notice how much smaller this number is? So one thing I want you to take away, I mean, what we'd want to know is why is that number smaller? And we might be able to deduce it by exploring the data set. We might figure out, oh, in 2005, only District X turned in the reports or whatever, however they collected this data. Or maybe the researchers know the answer to that question. Or maybe it is not at all known why that number is a lot lower. But I think it's probably safe to assume, given that the stop started on January 1st, that there's nothing that's really safe to assume, but depending upon what questions you're trying to answer, you might want to consider excluding that year because it has so few counts. You might think, oh, what if this is a really biased set of my data? But you wouldn't want to throw it out unless you had like a good reason to. So anyway, that's a bit of a side point. But getting back to the essential question of working with dates in pandas, did anyone use a different method?
I cast the date, so p.2date
Time.
.dt.year.
Got it. So let me pause at that part. So there's a data type in pandas called date time, and it has lots of useful features. So I'm going to, this is one place where I actually want you to type these things so that you create a certain column a certain way, and we'll use it in future exercises. So there are 2 lines of code I want you to type, and then I'll talk about them. So the first is create it's actually a series called combined, and what you're going to say is ri.stopdate dot stir dot cat ri dot stop time, comma sep equals space. Okay, let me make sure I did that right. Stop date stir cat stop time sep space. Okay, so this is a string method. I'm saying cat is short for concatenate. I want to concatenate stop date and stop time, the two series that are next to each other. I want you to concatenate them into the same series, still a string series, and separate it by a space. Okay, so that's what I'm doing here. All right, so if you run that and you just print it out, you'll see that combined is a pandas series, and it has the date and the time in the same column. Okay, I know it looks a little clunky, but that's the best way I know of to combine two columns that are strings. Okay, so the second part of that is what this gentleman here was talking about, which is taking a date and a time, though you can actually just do it without the time, and you pass it to a top-level function called pd.toDateTime. So I want you to type this line of code as well, just to be clear. And what that does is takes that series and converts it into the datetime data type. And we're going to store it in a new column called stop datetime. Okay? So instead of stop date and stop time, we now have stop underscore datetime as a new column. Okay? All right. So those, I will try to keep those up on the screen. But I will scroll back to them in a second. But I want to show you the D types and show you that stop datetime, our new column, is a datetime 64 column. Okay, so that is its data type. And I'll leave this up here for one more second. So if you haven't caught up, finish typing that. Okay. And then with that knowledge, before I interrupted you in the second row, you were saying how to use this to figure out the year. So what do I type to get the year from this? Great. Awesome. Great, great, great. So he was just saying, okay, so just like string methods have like a series dot str dot something, datetime methods have a series name dot dt dot something, and these are various attributes, and we've got year, which is useful. You could even do like weekday, and it can tell you what day of the week it was, and you can, check the month and all kinds of things. So super useful to have your dates and date time format. But in this case, we just wanted the year. And then like he was saying, you could do value counts. And then he added on there that he did a sort. Though it is sorted, value counts is sorted in descending order by default. So it's going to be the last one. But he was saying, oh, well, I sorted the values. And then, which does ascending. And then he picked off, I think, the first one. It's just, oh, okay, got it. That dot index 0 or something like that. Anyway, there you go. So if you want just the number, that would work. That would work quite well. So I'm just going to back this off just to have the full thing there. But that's the other way. Yep. No, you can just have a date without a time, and it can be date time. Maybe there's a case where that doesn't work, but I'm pretty sure that will always work. And you'll notice that it just guessed. It just figured out. The reason I included time is because we'll use it in a future exercise. Okay, so my lessons there, I think I've already said. My lessons were, for this one, were just, let's see. Number 6, consider removing chunks of data that may be biased. If exploration leads you to believe, okay, this is biased, and for the purpose of my question, it should be removed, you should consider that, and use the date-time data type for dates and times. Okay. All right. Any questions? All right. Next exercise. Whoops, not what I wanted. There we go. Next exercise, number 7, How does drug activity change by time of day? And the columns I want you to use are stop date time and drugs related stop. I would have preferred if they called it drug related stop, but they call it drugs related stop. So don't let that typo throw you off. Or it's not a typo. Don't let that spelling throw you off. How does drug activity change by time of day? Use what you have to try to kind of figure that out. So I'll give you a few minutes for this one. right, I think we'll go ahead and go through this one. All right, let's start with talking about the drugs-related stop column. And probably the first thing, you need to know is what is this data type? And you see it is a Boolean column. And so just like before, with where we had a Boolean column and we wanted to know a rate, we can just take the mean to see the percentage of times it's true. And this answers the question, what percentage of time during a traffic stop is it considered drugs related or drug related? Okay, so it's less than 1%. We assume what this means, and we could look it up, that like drugs were found. I assume that's what the true value means, but we could look it up in the documentation. So the way I chose to interpret the question is, for each hour, what is the rate of drug-related stops? Because obviously we don't know about drug, like this data set is about traffic stops. So obviously that's all the data you have to work with. So if I'm asking you about drug activity, you're going to say, well, I've got, which stops are drug-related, and we can kind of assume that drug activity is a general term, so we'll say a drug-related stop counts as drug activity. So what we're going after is, for each hour, what is the rate of drugs-related stop? Because if it's really high at night and it's really low in the morning, then we can say, oh, well, drug-related activity goes up at night and comes down in the morning. That was kind of where I was headed, and we'll see this in code. So I'm going to show you a piece of code that won't work, and then I want you to tell me how to fix it. Okay? So this is the concept I would have used to answer it. So for each hour, and notice I did not split hairs like on minutes. So I didn't say, oh, well, we're looking at a general trend, so we don't really care about minutes. So looking at hours is good enough. So for each hour, what's the rate of drugs-related stop? Okay. So this is the concept I want, okay, to use to answer this question. Why won't this work? You do not have a column named hour. So there is a simple way to solve this. Can someone tell me what that is? Yeah, back there. Yep. So all you do is you actually just throw in the full name of ri.stopDateTime.dt.hour. Okay. And this looks kind of funny because most of the time, I assume you're used to seeing group by's string which references a column name, but you can actually group by things that aren't column names if you just specify them in full. And we get this. And that's pretty cool. So these are hours 0 through 23. 0 is midnight. 23 is 11 p.m. So that's what it's doing. Did anyone take this and plot it? Or plot something like this? Okay, a bunch of people plotted. Great. And how might I plot this? Dot plot. Someone said that. Love that. So just throw a dot plot on the end, and you get the plot. And look at that. Well, I mean, it looks like in rough terms, the rate of drugs-related stops goes down during the day, comes up at night. It drops sharpest at between 3 a.m. to 5 a.m. So I guess everyone goes to sleep or whatever. And there you go. But notice that all we did is say dot plot. And so we were plotting a pandas series, and the default plot for a pandas series is a line plot. So we didn't even have to specify anything other than dot plot. There's no plt dot show. There's no plt dot anything, which is great. Wait, let me take that back. If you're not in Jupyter, you probably had to do a plt dot show. Sorry, forgot. I'm in Jupyter so much I forget the rules. But question back there? Oh, okay. You just did by dot time, like that. That is Oh, oh, okay. I would argue this is harder to understand. Is this exactly what you did? Okay. I mean, to me, the hour one is easier to kind of make sense of. And I think it still answers the question. I actually didn't even know the dot time existed as a date time parameter. So thank you for teaching me that. Great. So sorry, again, plt.show if you need to, but if you're in Jupyter Notebook, you don't have to do the plt.show. But you do have to do the import. Anyway. Any questions about this? All right. So my lessons there, use plots to help you understand trends. Those raw numbers were pretty hard to digest in my mind. And I really encourage you to create exploratory plots, not like production-ready plots, but exploratory plots using these Panda one-liners. Or you can save an intermediate object if you like that method better. But I'm a big fan of just throwing .plot on the end and using that because it just saves time rather than writing a bunch of matplotlib. So, all right. Let us, yeah, please.
I got a different answer with a different query, yes.
You got a different answer with a different query. What was the answer? Or
Different distribution of time.
oh, okay. Does it look anything like this?
Um,
Or does it dip during the day?
I'm just eyeballing it versus plotting it. So it seems like there's two ways to interpret the question. You said drugs-related activity.
Uh-huh.
So I was counting the stops per hour, which is
Right. Right.
which would
Great
give
point.
rise to the number of police officers you might have on the street.
Right. So it is sorry, to basically repeat, I was using a rate and he was using a count. And you could probably argue both ways as to which. They sound equally valid. Actually, the more I think about it, at first glance of hearing that, I'm thinking, oh, a count sounds good too. Or maybe even better than the mean. So I think there are definitely at least two ways to answer this question. And you could argue that a count is more relevant. Like if you're like, how many people are out on the road right now that if they were stopped would have drugs or something like that, then the count is more relevant than the mean, which is like for a given police officer up at a given time, what is the rate of drug-related stops? It's kind of like different ways of answering the question. Thank you. I will probably, I'm happy to take a look afterwards at the, oh, got it. Got it. All right. Great point. Let us move on to the next one, and it is number 8. Whoops, sorry. 8. Do most stops occur at night? So nothing having to do with drugs, just do most stops occur at night? And this one, I want you to apply what you've just learned, and that's all I'll say. Apply what you just learned to answer this question. All right, I think we're gonna go through this one. I don't know if you feel rushed. I'm thinking like the idea I had for the answer is pretty simple, so I don't want you to like, be like, oh, I can't figure this one out, and it's just a small change to what we've already done. So, I know that part of this is like, I didn't define night, and do I want a yes or no answer? Do I want a plot? And I left that ambiguous. But I was hoping that one step you might take is thinking like, well, I can use hour to determine time of day, and so I'll just start with stop date time dot dt dot hour, and then take the well, you could just start with the hour, and I can get the hour from that. So we're just using our date time attribute of hour, and then you might say, oh, well, I'll just take the value counts of that. And now I know that the most number of stops occurred at 10 a.m., followed by 9 a.m., followed by 11 a.m., followed by 2 p.m., followed by 11 p.m., followed by midnight, etc. And then we talked about the previous exercise, like, oh, well, it's easier to understand these trends if you have a plot. So you probably thought, well, I'll just throw in a dot plot. So this is what I was hoping you would kind of get to. And then you'd get this, and you'd be like, what have I learned? And you're not quite sure what you've learned. I love those plots. What is the thing I need to do to, quote, fix this plot? Sort what? Sort the index, sort by hour. That's what I heard. So let me clarify that. Let me go back to the value counts. Value counts, in case you never noticed, it outputs a series. Okay, so the thing on the left is the index, the thing on the right is the actual value. It is a series, and series have two methods for sorting, sort index and sort values. And value counts does a sort values in descending by default. You don't have to do it. So if we just say sort values, for instance, we'll just be sorting the values which are on the right. And if we do sort index, we sort on the left, okay? And it turns out that pandas does not assume when you do that line plot, it doesn't assume, oh, well, you meant to sort it, so I'll go ahead and sort it for you. So it doesn't do that automatically. You need to sort it if you want this plot to look right. And what we see, do most stops occur at night? Well, I guess it could depend how you define night, but it seems clear to me that most stops occur during the day. Okay? Yeah, please. Right. Sure. So you were essentially what he was saying is he actually decided, okay, night is from, what did you decide? 10 p.m. to 4 a.m. is night, so let's filter by that, right? And then decide, well, that's a valid way. And let's see, so ri.stop date time dot dt dot hour. I know it's really long to type. If you're going to type that a bunch of times, you could just create it as a column. But you would do something like this is, let's see, greater than 4, and because we have multiple conditions, we would put them in parentheses. So greater than 4 and ri.stop datetime dot dt dot hour is, whoops, yeah, no, that's right, and is less than, what did we say, 10 p.m., 8 p.m.? Okay, so like 22. So we could take that, and that would be that data frame, and you could just do dot shape, and you could see, all right, 68,000 rows are between daytime, and ri.shape in general is 90,000 rows. So it looks like 20-ish thousand rows are between the night hours. So this would be another way to do it. You wouldn't get the benefit of the graph, but you would get like raw numbers to look at. Yeah, in the back.
I thought since you gave a hint that you should use structure,
Right, right, yeah.
I just replaced the min with the count, and that gave me the same result.
Oh, that sounds wise. So you just, let's see, took this, but wait, you didn't, you still selected drugs related, or you did not select anything. You've just replaced this with .count? Oh, let's take a look at that. All right. .count. Let's just take a look at this. Uh, oh, you still selected just a column. I let's take a look at this after. I don't want to try to decide what I think of this right now. Right, but every row is a stop, and at the moment, I'm a little confused by the different lines. If someone is like, I know the answer, please tell me right now. Yeah. Ah, that sounds right. It's because of missing value. If for any column that has no missing values, I will get the right plot. But if I choose a column that has missing values, I'll get a plot that got it. Thank you for that. So he's just saying if we know there are no missing values in stop date, and that looks identical. Great. Love it. Very cool. Yeah, please.
On the like the if you go up a little bit
Yeah.
to the dot shape
Okay.
solution, is there a way that you could like graph like somehow show counts here instead of because this tells you how many stops occurred at night or what like however you define this.
Right.
How do you get the other half or like can you show that in a bar plot? Is that
I mean, in this case, we've only got two. So you could do a bar plot version of this, and it would just be bars of those heights. So that,
like let's say you had three options, right? Let's say you had like daytime, evening, like night.
uh-huh.
Like what would you do to get something that's easy to understand?
Right. She's asking if you decided there was a daytime, an evening, and a night. So did I? Yeah, daytime, evening, night. You had three categories, and you wanted to show the number of stops in each of those categories. Okay, I would map. Actually, yeah, I was thinking if there was an exercise, but I would map the hours to categories, and then I would just plot a bar plot of that category. So that would be one way. Back there, did you have? Okay. All right. Great questions. Love these. All right. So my only lesson in this particular exercise was to be conscious of sorting when plotting, because when the sorting, if it's expecting it sorted and you don't sort it, it's not going to do it for you. So that's all. All right. The next one, oh, this is a good one. I mean, they're all good, but this one is especially good. All right. Number 9. Find the bad data in the stop duration column and fix it. Okay? So I am not defining for you what is bad data, but I'm telling you there is bad data in the stop duration column. So I want you to find it, and then I want you to fix it. And I'm not going to tell you how to fix it, but things I've said previously today should give you a hint as to how I want you to fix it. Okay? So this one's a little more complicated, and I will give you a little bit more time than usual on it. But if you get done early, feel free to help your neighbor. And if you're stuck on a particular step, let me know so I can, because it's kind of a potentially a multi-step process. All right. It seems like, well, there are probably a lot of people either still working on it or just kind of like, I don't know. But we'll go ahead through this one, and then that way, hopefully, we can get in one more before we close out for the day. So the first big question of the day is, what counts as bad data? And I saw a lot of people do the same thing that I was thinking you would do, which is just, well, let's look at what's the data that's in there. And I did see some folks set this to false. And so the first question is, do I think the missing data is bad data? And I did not, but you could probably argue that it is, or that I meant for you to fix that data somehow. It's not what I intended, but it was ambiguous so that you would have to think through these things. What I was trying to focus you on was this 1 and this 2. And have you think, is that 1 minute? Is that 1 hour? Is that a typo? Why are those there? I tend to think that because there's only one each of them, that it's probably bad data. And by bad data, I mean erroneous data. So like mistype, or who knows exactly how it got there. Okay. So the question becomes then, how do I fix it? Sorry, what does it mean to fix it? And what does it mean, and how do I do that process? So in the first question of like, what should we do? I've talked with a lot of you about this, but what's one way to fix this? Yeah, over there.
Assume that they meant hours and change 2 to 120 minutes.
Okay, you could assume that it means hours, and change 2 to 120 minutes and 1 to 60 minutes. Or you could put them both in the 30 plus minutes, because that's more. What would be another way of handling it in the back? You could use the stop time. The stop time is actually the time of day. Oh, okay. Oh, got it. Right. The stop time column is the time of day at which the stop occurred. It is not the length of the stop. Yep. You could remove, one suggestion someone had, or one idea someone was executing, was remove those rows. Another option is to replace those data with something else, and the thing we were driving towards is maybe we should set it as missing. So that's kind of a common strategy. If you think data is bad, you set it as missing. Whether or not that's the right choice, you make lots of choices when working with data, and the most important thing is to document what you're doing and make it reproducible so that when someone bases an analysis on your data, they know what assumptions you made. And you would say, or you would put in code, I fixed the data as follows because I assumed these were typos. So that if later they figure out they're not typos, they can change your code and change it. So if we go the route of fixing this by setting those two values, 1 and 2, to not a number, NaN, missing, the question then is how to do it. Now, I saw one person who had, and I'm sure there were more, that used the replace method, which I thought was quite nice, and I actually was not even familiar with that method. So I have a different method that I'm going to use because it supports what I want to teach, and it's useful regardless. As we've talked about, there are always multiple ways to do things in pandas. But this, I think, will be a fun little exercise, and it's called debug my code. All right? So, all right. Let's see. I want to make, all right, stop. One. All right. And I know there are things wrong, but I'm going to ask you about it in a second. Equals NaN. All right. So if you recognize this code, you're like, okay, what is he doing? He's filtering the data frame for stop duration values of 1 or 2. He's taking that filtered data frame and selecting the stop duration column, and then he's replacing it with NaN. All right. There are 4 things that are wrong with this code. Who can tell me one of them?
So like that string NaN is not the same.
Okay. NaN is not a string. Now, I will actually fix that last, so let me come back to that. But thank you, that's one of them. Next. There's no in place because we're not actually running a pandas function here. We're just doing maybe assignment is technically a function. I don't know. But it's an assignment statement, so I guess it's not a function. There's no function to cause in place. The parentheses? Yep. So when you're filtering a data frame by multiple conditions, you use parentheses around each condition. It's just required, okay? So that is another thing that's wrong. So let me fix that. What is the next thing that is wrong? 1 and 2 are strings, not ints. And if you look at ri.stopDuration.dtype, it is an object, which is often but not always a string. But the one thing you can be sure of is there are no ints in there. So it is actually a string. So we can do that. All right. There is one more thing wrong with the code that is hard to kind of see, so I'm going to actually run this code, and then we'll talk about the next thing that's wrong. I think I've got it how I want it. Okay. All right. Uh-oh. Setting with copy warning. What is the appropriate way to handle a setting with copy warning? Ignore it. That is what everyone does. No, you should not. Let me show you why you should not ignore a setting with copy warning. The question is, did the operation work? Despite the warning, because it's not an error, it's a warning. Did the operation work? So how many people, by show of hands, think the operation worked? And then I'll ask, 0? No one thought it worked? Okay. How many people thought it didn't work? Okay, and the rest are unsure. Okay. ri.duration.valueCounts. Let's see what we got. And nothing has changed. Ooh, it's a warning, and yet it didn't tell you, well, this didn't work, but it didn't actually work. In other words, that assignment statement, it did happen, but it just got thrown away. Okay? So, what is the tweak to this code? So that was the final thing that was wrong with this code. And we're coming back to the NaN point. But let's pretend NaN was a string. But I just want to fix this code. How can I subtly adjust this code such that it will work? Using loc. Love loc. All right. So a little subtle adjustment here is to use loc. Okay? And the format of loc is which rows do I want, comma, which columns do I want. So in this case, I've already told pandas what rows I want. And so all I do is I say comma, stop duration. Okay? So I take the stop duration from outside the parentheses and move it inside. Okay? So ri.loc, which rows do I want? I want the rows that match these conditions. This OR condition. Which columns do I want? I want the stop duration column. And for all of those values, I want to set them to the string NaN. Okay? So we'll run that. No warning this time. And when we run our value counts, what do we get? All right, we've got 2 NaNs. But then you're like, wait a minute. NaNs are excluded by default with value counts in other pandas functions. So you say drop NA equals false, and now we've got a very confusing situation where you've got 2 NaNs in the list. And one of these is the real NaN, and the other is the string NaN. And this is why the woman up front said NaN is not a string, and you should not do this. Now, we can still fix it, but NaN is not a string, so we've created some confusion, but we can still fix it, okay? So the answer to how to fix it is we're going to do another .loc. But what we need, NaN, in case you're wondering, is how do you set something as missing? So you can import NumPy, and then what you're looking for is called np.nan. Okay? So in this case, from where we're at, the best solution is to write our loc again, and we're going to say, what rows do I want? I want the ones where stop duration equals the string nan, and then I want to select the stop duration column, and then assign to it np.nan. Okay? All right. So you can stare at that for a second if you're like, what is going on in that code? But let's take a look at the value counts once again. You will see the missing value is now missing, but we can say drop NA equals false. And there we go. We've got our 5335 NANs instead of 5333. Yeah.
So, in that second argument of the dot
Uh-huh.
stop duration,
Right.
can you change more than one column at a time in that case? Like, so let's say you want to remember that these were the nans that weren't originally nans, and you want to add a second column, right?
Uh-huh.
In place, right? So, say like.
Right.
or whatever.
Right. Okay. She's asking, could we, within the loc, affect a second column that doesn't yet exist, like a second column called rows I've changed, okay? And it defaults to false, and then you set those values to true or something like that. Can you do that at the same time? Well, you can't do it at the same time in terms of creating a new column, but if you already had a column called, like, let's just try it. I'm actually not sure if this will work, but if I want to change two, I don't think this is going to work, but we'll see. Stop date, let's just say. Can you set both of, I don't know. Well, who knows? Oh, well, we've already changed the filter. So, sorry. Because I ran this line of code already, they're already, because I've already ran the old version of this line of code, they're already gone, so I can't, without playing with it more, test it to see if it would work. So I'm not sure to the answer. We're actually at just a couple minutes left, so I will answer any more questions about this one, and then I'll wrap up. But, yeah. Okay. Really? You know, someone else mentioned that, and I was like, I never thought of that. And that sounds great. And I think if it worked, then I assume that that is a valid strategy. Yeah. Cool. All right. Well, that saves you from having to type import numpy just to, like, get the NaN. You folks have lots of cool tricks for me. And I'll write down that you can use replace, which I did not know about either. So lots of cool tricks. All right. It is, oh, please, yep. You can. I mean, can you use it and set multiple columns of values to NaN at the same time? And you're saying the answer is yes. Okay, cool. Great. Loc, it's a powerful tool. You should, if you're not familiar with Loc, you should use it because it allows you to do lots of flexible selection by label. Okay. As I was saying, it is 4:38, and as I recall, this ends at 4:40, unless I'm, is that right? 1:20 to 4:40, yeah. Okay, so I'll just wrap up quickly. I'm so sorry that we didn't get to more because I had so much more prepared. I slaved over all these exercises, and we only got to some. But I kind of expected that because you know, it takes time to go through these things. So I will be posting all the code from today with some amount of comments on GitHub. You can check it out. It's this same repo that you've already got pulled up. In terms of kind of some final closing thoughts, and then I'll be staying after for any questions. If you liked my teaching style, feel free to check out Data School on YouTube, just youtube.com/dataschool. And I've got lots of tutorials, mostly about pandas and scikit-learn, but some other topics as well. And if you really want to follow along with more Data School stuff, you can go to my website, which is dataschool.io, and I've got a newsletter, which is where I announce new courses and webcasts and tutorials and stuff like that. Very soon I have coming out a interactive online pandas course, and if you end up taking it, you'll notice it uses the same data set, but it asks some amount of different questions. So if you take it, I hope you enjoy it, and you'll have a leg up on the competition because you'll know some of the answers. So I have that coming out soon. I do have some Data School stickers and magnets sitting up front. If you're interested, feel free to grab one. I'll be here through Sunday, actually through Monday morning. So if you have other pandas questions or questions about data science or any scikit-learn, any of those things, feel free to grab me during the rest of the conference. Just a reminder to please do this at the very top. There's this survey. It's bit.ly/usingpandas survey. So I'd appreciate it if you would take that and let me know your feedback. And that's it. So thank you guys so much for joining me today. You were really excellent, and I had a lot of fun. So thanks again.